Today in the workshop, it's a brand new year. I'll show you some of the projects I worked on in 2019 and discuss some new changes in store for 2020. Have a happy new year and welcome to the workshop. Hello and welcome to the workshop and welcome to the year 2020. A new year has dawned upon us. Some people consider this to be the beginning of a new decade as well, although I'm of the school of thought that says the decade starts next year because there was no year zero. But whether or not you consider it to be a new decade, it is certainly a new year and time for a lot of new beginnings for many of us, and that is true here in the DroneBot workshop. So today I want to tell you a bit about what is going on here in the workshop going forward. I will have a new video out for you in a couple of days as well. And the first thing that's going on is you may not be seeing the videos as frequently. I'm going to try to still get them out every Sunday, but I'm going to miss the occasional Sunday as I have recently. And the reason is I want to focus this year more on quality than quantity. Last year I was really trying to go for quantity, and I feel that the quality of a few of those may have suffered, and I apologize for that. There's a lot involved in making one of these videos, as you might imagine. I've got to get together some experiments, write some code for it, test everything, film everything, make the animated explainers and graphics to go along with the video, write an article to go along with the video, and put it all together all within the space of a week. And at the same time, I'm also working on a robot project. And as I'm now a very old man, I had a birthday recently, I'm into my 7th decade, it's a little too much for a one-person operation like myself. So although I'll try to get the videos out to you every week, I will be missing the occasional one. Now the best way to find out about when these videos come out is of course to subscribe to the YouTube channel. And when you subscribe, you'll see a little bell notification. Hit that bell and you will be advised every time I create a new video. Now, another change in the workshop is the way that I'm taking suggestions for the content of the video. Last year we were doing it with the newsletter, and it worked out very well for me. There was a link to a survey in every newsletter, and you could go to that survey and give me your opinion on the content you wanted created, have some opinions on the content I was planning on creating, and it was very helpful in getting out the content that you would enjoy me making. Well, this year I'm moving that survey over to the DroneBot Workshop forum, and that way you will be able to do the same thing, but you'll be able to see the results and you'll be able to discuss among each other what content you want created and the pluses and minuses of doing it, and that way I'll get to really know what it is you want me to make. Now if you haven't joined the forum yet, it's quite easy to do. It's at forum.dronebotworkshop.com. There's a new sign-up procedure in which you send me an email as opposed to filling out a form. We're doing that because we had too many spam bots joining, but it's a great way of signing up because it allows me to get to know you personally when you get onto the forum, so it's kind of a win-win situation. Now, we're also going to be having the newsletter a bit more frequently. Previously, the newsletter came out about once a month or so. This year, if I'm making any New Year's resolutions, and I usually don't make them, except I always make one resolution I know I can keep, so this year I'm not going to be cruel to giraffes, for example, and living in Canada, I could probably keep that resolution. But this year, another resolution I'll make is to try to get more frequent newsletters, about every 2 weeks, so they don't disturb you in your inbox, but keep you informed about what's going on in the workshop, because I have a number of new changes here, a number of new changes I've made to the website, and plus some new ones coming up, and I want to keep you informed in that. So if you haven't joined the newsletter yet, please just hit the link right below the video and do that. Now today what I want to do is go and look back at some of the stuff we've done in 2019. It was a great year here in the workshop. It had its ups, it had its downs, and I had a lot of cool projects that I created that a lot of you seem to enjoy. So I want to go over a few of those. You might be watching this on New Year's Day and you just want to do some binge watching. Well, that would be great. So these are some videos you can check out, or you might be looking for a new project for the new year. So let's go and take a look at some of the projects that we've worked on in 2019. Now here in the workshop, we really like making things move. We like making robots move, robot arms move, and a variety of different devices using a number of different types of motors. A lot of the times we focus on very tiny motors, but occasionally we need to work with big motors. And so I did a video on how you can control a large gear motor with an Arduino. Check it out. So as we can see, changing the pulse width modulation frequency definitely has an effect on the sound that our motors make. However, what effect is it having on the motor performance? Now, one thing about PWM frequency is as the frequency goes up, sometimes the efficiency of the motor tends to go down. There's kind of a graph you can follow for that, and there comes a point where if you increase the frequency, you're going to really start decreasing the amount of torque that the motor can give. And of course, we want this to be a high torque motor. That's why I bought these big motors, and they're going to have to carry a fair deal of weight around, so I want them to be able to do that. So in order to test this, what I've done is I don't have any scientific lab testing that can measure torque, but I decided to give it a real-world test. And here's my real-world test. I'm going to carry this around. Now, this is a 10-kilogram bag of road salt. Now, for those of you who don't live in winter climates, you may not be aware that in the winter we spread down salt and sand in order to provide traction on the ice, and the salt will actually melt the ice as well. And this is 10 kilograms. For those of you who don't speak metric, 10 kilograms is 22 pounds, which is why I'm straining a bit holding this thing. Now, we're going to put this onto the robot and have it drive it across the room. I'm going to start off at the same PWM frequency the Arduino used, 488 Hertz, and then we're going to move the frequency up and see how it affects the performance of the robot. So let me put this thing down and we'll get going with that test. Okay, we've got the 22 pounds, 10 kilograms of salt on the base, along with a board which probably weighs close to a pound in itself, and we're set to go. I've got the PWM set at 3000 Hertz, and as you can see the square wave over there, right now the power supply is on standby, which is why it's not moving. It's at a 50% duty cycle, so it should go at half speed, and I've only got a little space over here I can test it in, but it should be good enough to see if we can at least move the motors, and here we go. And it seems to move rather well. Let me reverse it and try it again. Reverse. And it looks like it works pretty well. Like it has no problem carrying 10 kilograms of load, plus that board, plus its own weight. So it's pretty high torque. I would say we have no problem at 3000 Hertz moving everything around. Now, large gear motors aren't the only large motors we worked with this year. We also worked with this beast, which is a very large stepper motor. So check out how we used an Arduino to control this device. So I've loaded the bounce example from Excel Stepper up to my Arduino. Now you can try some of the other examples as well. All you have to do is remember when you're defining the stepper object to use the syntax that I showed you, and you can change any of the existing examples. You can, of course, also use other code that uses Excel Stepper using one of these driver modules. So all that remains to do is to put some power on. And we've got it right at the end. Now, Excel Stepper, what it does is it accelerates the speed, and then it rotates, and then it decelerates, and comes to a stop, and then reverses, and does the whole thing all over again. And there you go. Now, one thing you probably can't hear, because I think my noise reduction technology is muting it for you, but on the stepper driver, the fan does come on every time that I power it up. And I haven't really felt any heat off of this. I ran this the other day for a few hours. There was a bit of warmth on the stepper motor. Of course, I'm not driving it at anywhere near its full capacity, its full torque. So what I'm going to do now is I'm still stepping this at 800 pulses per revolution. I'm going to turn the power off for a moment, And I'm going to use the dip switch on the side. Now they have a diagram here that tells you the microstepping as well as the current setup. And so you need to set this up correctly. Make sure not to exceed the current of your stepper. But I'm going to press this one down, and that should cause it to only use 400 pulses in order to do a revolution. So let's turn it back on. And it is moving faster, definitely. And so using microstepping and the speed controls in Excel Stepper or whatever sketch you're using, you can control both the speed of your motor and to some degree its torque, because different microstepping modes will give you more torque. Now, not every motor that we worked with this year was a massive motor. We still worked with those tiny little motors that come with those little robot car kits. And most of the time we use the L298N H-bridge to control them, because that's the standard way of doing it. But I found a better H-bridge to work with. It uses MOSFETs instead of transistors, so it is much more efficient than the L298N. And the beauty is you can actually take the code you've already written for the L298N and substitute this new H-bridge in for it. So let's take a peek at that. And so here's our demonstration. As you can see, I've got the two potentiometers. This is A and this is B. And I've got my two motors mounted up here with a couple of wheels on them so we can watch them spin. And this is A and this one over here is B. I've got my power supply, which in this case consists of 4 AA batteries to provide 6 volts. Here on this breadboard, buried behind all these wires, is the actual motor controller itself, the TB6612FNG, and of course my Arduino Uno. And so now that I've got this all hooked up, let's just simply take a look at it working. I'm going to turn the pot for motor A, and as I turn it up, got the speed, and do motor B. And I can vary the speed for both motors. Now, one thing that you're going to find that you need when you're working with electronics is a source of power for your projects. And of course, there are many ways of providing electricity. You can use batteries, you could use a USB power adapter, and with Raspberry Pi and Arduino projects, you quite often can use the Pi or the Arduino itself to power things up. But there comes a time when you're going to want an actual bench power supply. And in 2019, I constructed 2 of these. Now, the first one I constructed used an old ATX computer supply, and it can supply you with 5 volts and 12 volts at a reasonable amount of current. So let's go take a peek at that project. Alright, now here's my supply. I've placed the front panel on, and I've fastened it down, and I've connected all the wires, so it's actually just ready to test. Now, I've got the switch on the back off. When I turn it on, the supply will go into standby mode, and you can see the standby LED. You can also see the power came on to my power meter, and that's because I'm powering it from the standby power supply. And again, the power meter is just an optional thing, but it seems to be working right now. Now, if I go and measure the voltage, however, I won't have any voltage right now on any of my outputs, and that's of course because the supply is in standby mode. So let's place it in the power mode, and the power good light comes on over here. You may be able to hear a little bit of fan noise, although it's a pretty quiet power supply. And now here's my 3.3 volts. It's actually measuring a little hot at about 3.5 volts. And my 5 volts is just about bang on. And my 12 volts at 12.17 volts is pretty good as well. And so there you have it, a bench power supply constructed from a ATX type power supply. And this actually will be a very handy unit, not only for the project I'm planning to use it for, but for my workbench in general. Now, of course, I'm going to tell you a little bit about this power meter in case you want to add one of those onto your project. So let's discuss that right now. Now that ATX Supply is an excellent piece of equipment, and if you don't already have a bench supply, I highly suggest that you go ahead and consider building something like that. You probably have an old ATX Supply that you can get your hands on from an old computer, and even if you don't, they're not that expensive. However, one disadvantage they have is that they only provide fixed output voltages, such as 5 volts and 12 volts, and while those are indeed the most common voltages that we use in electronics, there are times when we need voltages that aren't 5 volts, 12 volts, or 3.3 volts. And so for that, I built another power supply, and this one has a variable output and a rather fancy display as well. So let's take a peek at that project. So here are the components I'm going to be using in my power supply. Of course, you could use some different components. You could certainly use a different case than the one that I used. And if you wanted to use different modules, that would be fine too. The principle basically is that I'm going to take this power supply unit, the one that is already certified and the one that works well, and I'm going to use it with this module in order to provide a variable voltage output, and a module over here that I'm going to be using for the 5 volt output. But of course you could add modules if you wanted a 3.3 and a 12 volt output. You could do that. Bear in mind you need to realize the limitations of your power supply. This one is 5 amperes, which is a fair amount of current, but when you start dividing it among a bunch of different outputs, you have to remember it's the total of all the outputs that you're going to be able to get. So here are the components. This is a case that I purchased, and I did want to make the case look a little prettier. I was going to paint it, and I was going to add lettering to it, but then I looked on my can of paint and realized that when you paint plastic, although it dries in an hour, it actually on plastic doesn't completely set to complete hardness for 5 to 7 days. And I wasn't willing to wait. However, I am going to be building this in a fashion that I can easily take it apart without having to unsolder anything. And so I will probably down the road paint this. I was going to paint the front and back panels, which are these two panels, white, and then I was going to paint the rest of this blue because that kind of matches up my workshop. And after I painted this one white and let it dry, I was going to use press-on lettering that I've used before on some of my projects and just label these things and then give it a coat of clear coat, and that should make it look very nice. And again, I might still do that down the road. So we're going to have to settle with a bluey gray power supply. But what I've done to the case, as you can see, is I kind of hacked out an opening for this over here. I measured this and hacked it out over here. You'll notice there's some extra little lip area over here, so to speak, because of these little tabs on the back of this that allow it to snap into place. Now, I know it looks kind of crude, but the bezel on this will completely cover this so you won't see it. And then I just drilled out some holes for the binding posts, and these are my binding posts over here. I've got two black ones, a red one that I'm going to use for the 5 volt out, and I was going to use the yellow one for the positive on the variable one, mostly because the controls on this are yellow and I thought that it might match kind of nicely. This is the coaxial power jack for the back, and I'm putting it over here on the back. Now if you wanted to, you could put a switch on that. I decided not to use a switch, but if I had, I probably would have put it on the back as well. And here's the hardware to mount that power jack. These little standoffs over here, these two are for this regulator board, and I'm going to mount it here. You might be able to see that on the bottom of the case over here I have drilled a couple of holes, and that's going to be where this mounts. And so it's going to actually be a pretty easy build. This is the rest of the hardware that came with this, the feet and some long screws that go through the case over here and hold the bottom and top together. So a fairly simple build. Before we start building it though, I want to test out these modules. So let's bring these over to the other workbench and give these modules a test. This is a variable one, so I also want to set it to have a 5 volt output. Let's go do that now. Many of the times when you're constructing a project, you need to add a display to that project, and there are a variety of displays that you can use. Last year I showed you how to use a couple of different displays, including organic light emitting diodes, or OLEDs. And so let's take a look at how you can use both I2C and SPI bus OLED displays in your project. Now here's our OLED demo wired up on a solderless breadboard with the I2C and power lines connected back to the Arduino. And so let's start it up and run the Adafruit demo. And it starts up with the Adafruit logo. And then it starts drawing a number of patterns. Now as you can see, this is a pretty bright display. I've got all the lights on the workshop on right now, and even under all my LED lighting, you can still see this very clearly. And it just runs through all of its different patterns. Right now it's showing a bit of text, and you can see how small you can actually make the text on one of these displays. And so it seems like our sketch is working. Now for our final look at the 32-line display, I thought I'd try something a bit amusing. Now I've got two of these 32-line displays over here, and they both have the same I2C address. In fact, on this particular display, I don't know of any way of changing that address. I've got them in parallel on the I2C data bus right now. Now these are displays. They are not sending data back to the data bus. They're simply picking it up. So although you normally don't want two I2C devices with the same address, in this particular case I think we'll make an exception. And let's take a look at what happens when I start the Arduino up. And it's probably what you expected would happen. Both displays are showing the exact same thing. Now again, this is working because displays are just receiving data from the Arduino. They aren't sending any back. If that was the case, you certainly couldn't have two devices with the same I2C address. And if you wanted to independently address these two displays, of course you'd have to use two ones that had different I2C addresses. But if you want to parallel a display, this is actually a pretty neat technique that you can use. Now one excellent type of display that you can add to your project is a touchscreen display, because this is not only a display, it's also a user interface, and it can be a dynamic user interface as well. And touchscreens are very versatile, and they come in a number of different forms, including resistive touchscreens and capacitive touchscreens. Now I'm going to be working with touchscreens a lot more this year, but last year I showed you the basics of using them by showing you how to use resistive touchscreens with the Arduino. It was kind of a touchy-feely episode, so let's take a look at a few highlights from that. Okay, so here's our display. As you can see, it's a very simple hookup. I've got the shield on top of the Arduino Mega, and the red, green, and blue LEDs through their associated dropping resistors are connected to 3 of the I/O pins on the Mega, and you can get at the I/O pins on the very end of the shield without adding an extra adapter or anything, so that's very handy to be able to do that. Now I've also got my serial monitor up. As you can see, it's already displaying that it's done the LCD test, it's found the correct driver, and it has determined the resolution of the display as well. So all that's left to do is to press some buttons and see what happens. So let's press the red one. And as you can see, of course, the red light came on and it stayed on. And you'll see on the serial monitor that the event of both pressing button 0 and releasing it has been recorded. Let's do it again. And we'll see again we've recorded another pressing and release event, and the light is turned off. It's toggled, and of course this works with all of the lights. And so you can see on the serial monitor as I'm doing it, the events are being recorded, and of course the lights are doing exactly what we would expect them to be doing. Now, if you wanted to, instead of hooking up 3 independent LEDs, a red, green, and blue one, you could of course just use an RGB LED, and in that case you'd be able to dial up 7 different colors. Now admittedly that's not the fanciest display, but it's a good start for getting to work with liquid crystal displays and touchscreens, and the next time we work with touchscreens we'll look at adding some additional controls onto our display. Now for 2020 and beyond, I want to start working more with artificial intelligence and machine learning. And so in order to do that, I need a platform to build upon. And last year I found what is probably the perfect one for experimenters. It's the NVIDIA Jetson Nano. It's a low-cost board that is capable of doing a number of machine learning and artificial intelligence applications. So let's take a quick peek at the Nano because we're going to be seeing a lot more of it here in the workshop this year. So here's the Jetson Nano development board. Now I've got it all hooked up, but I'm going to unhook it so we can take a better look at it. So I'm just going to disconnect this, which is the power supply, an Ethernet cable, a USB, which in my case is going to a keyboard and a mouse, and an HDMI. And we'll take the Nano board off. Now, before we look at the board, I just want to show you the box. The box came with this little stand, which is rather amusing. You place that in here, and then you can just place the board on here, and it gives you a convenient place to work on the board, which I guess is pretty cool. Now let's just take a look at this side of the board over here. As you can see, we have a series of jacks on there. The Ethernet, that's a gigabit Ethernet. There are 4 USB 3 jacks. There is a HDMI and a DisplayPort output, and these can both be used simultaneously, by the way, both at 4K video. And over here is a barrel connector that you can use to supply 5 volts at up to 4 amperes if you want a higher ampere supply. Now this connector over here, the micro USB, is only used for an up to 2.5 ampere supply. So if you want to use this in high powered mode, you're going to need to use this power supply. And when you do use that power supply, there is a jumper here that you're going to have to jumper in order to take power from the barrel connector instead of the micro USB connector. Now down on here is a CSI connector. Not certain how well you can see that. That's the connector for the Raspberry Pi camera. There's a few other I/O connectors over here, power over Ethernet connector down here. Down on this side, you'll see a 40-pin connector. Now that's a 40-pin GPIO, and its output pins are programmable, but by default, this is the same GPIO that the Raspberry Pi uses. So you've got the ability to use some Raspberry Pi designs with the Nano, although of course you won't be able to put a hat on top of here because of the heatsink. Now the heatsink itself sits on the Nano module. The Nano module itself is an SO-DIMM module. It's mounted on a socket. I don't know if you can see the socket over here. And when you remove it, and you'll have to take these 2 screws off to remove it, there is another connector underneath that's an M2 type connector that can be used to add a Wi-Fi and Bluetooth connection to the Nano. Now you'll also notice that the heatsink has 4 threaded holes in it. This is for mounting a 40mm fan if you want, and this connector over here is for a 5-volt 40mm PWM controlled fan, so that's where you would connect it. And so that is the NVIDIA Nano in a nutshell, the Jetson Nano. Now, one of the neat devices we worked with last year were Rotary Encoders, and they can be used in multiple applications. In one application, they can be used as a fancy potentiometer. They're capable of continuous rotation, and they're much more accurate. Another way you can use a rotary encoder is on the back of a motor in order to determine the motor position. And I'll show you how to do both of these in my rotary encoder video. So here's how we're going to hook up our rotary encoder test. You will need an Arduino Uno, a rotary encoder module, a couple of LEDs. I'm showing a green one and a red one, but you can use any 2 colors that you like. And a couple of dropping resistors for those LEDs. I'm showing 220 ohms here, but any value from 150 to 470 ohms would work well. We'll begin by connecting the ground from the Arduino to the ground pin on the rotary encoder. We'll connect the Arduino's 5-volt output to the V+ pin on the encoder. Digital pin 4 on the Arduino will be connected to the CLK pin on the encoder, and digital I/O pin 5 on your Arduino connects to the DT pin on the module. Now connect pin 8 of the Arduino to one side of a dropping resistor. Connect the other side to the anode of one of the LEDs. This will be the LED that indicates a clockwise rotation. Connect pin 9 of the Arduino to one side of a dropping resistor, and the other side of that resistor to the anode of the other LED. This will indicate counterclockwise motion. Finally, the ground of the Arduino is connected to both of the cathodes on the LEDs. And this completes the wiring. Now let's take a look at the sketch we'll use to test our rotary encoder. Now, one thing that we've worked with a lot in the DroneBot workshop are sensors, specifically sensors that can detect movement. And we've seen ultrasonic sensors, we've seen sensors based on light, we've seen passive infrared sensors, and even using video cameras to detect movement. But one of my very favorite sensors is one that we worked on last year, and it makes use of microwaves. It's a very inexpensive device, and you can even use it without an Arduino or Raspberry Pi. Let's take a peek at that microwave sensor. So here's a demonstration of the transmitter and receiver. This is my transmitter side with the red LED and the receiver side with the blue LED. And as you can see, whenever I make a movement, the microwave sensor is picking it up over here and transmitting that over to here. Now, admittedly, these are only a couple of centimeters apart, but the range of these 433 megahertz modules is fairly reasonable. You should be able to get it transmitting throughout your home, especially if you take care of the antenna. You'll notice that on these devices I've got some curled up wire over here, and that creates a bit of an antenna. Now, if you want to learn more about creating an antenna and optimizing these devices, I'd advise you check out the other video that I did on the 433 megahertz modules. It goes into much more detail. But as you can see, this seems to work pretty well. Whenever I make a movement over here, that movement is transmitted and picked up over here. So now we can remotely sense movement using this arrangement with two Arduinos and the RCWL0516 sensor. Now, I could probably go on all day showing you videos that I did last year, but of course we have to stop somewhere. But I'm going to show you one more. Now, last year I did a video on using gyroscopes, and in that video I put together a very simple little electronic level that used LEDs in order to indicate whether you were level or not. And it's actually a pretty cool project. I just built it on a little stick because it was an experiment, but you could put this into a case and actually make it into a permanent device. And so if you're looking for something to build into the new year, this might be the ticket. So let's take a look at that. Alright, here's our demonstration all hooked up. I'm going to plug the power into it right now. And when you first start off, remember it has to calibrate itself, so you'll see nothing on the display at the beginning. And there we go, we have a display, and also our center LED is lit because everything's pretty flat. Now let me lift up the end a bit, and as we go up the yellow one and the red one, and notice the pitch values there are negative. I'll bring it back down to the center and move it up over here, and they're positive. And of course, as we go above, it just stays with the red LED because we've exceeded 2 degrees. And move it back down into the center. You can also see the roll values when if I rotate it, you'll see that the roll values are changing as well. And so there you go. It seems to work very well, and you could actually use this as a permanent project if you wanted to put it into an enclosure and maybe use a smaller Arduino with it. And so our electronic level meter seems to work quite well. Now, before you run off and start watching a few of the other videos, and I hope that's what you're going to do after this, I have a bit of a personal message that I'd like to deliver to each and every one of you. This channel has been a real adventure for me. I started off as someone who'd never appeared in front of a camera before, and I've taken it to the point where we now have as of today, 145,000 subscribers. And it really means something that 145,000 people took the time to click that little subscribe button because they wanted to see more of what it is I'm producing. And back in July last year, July 27th to be exact, the channel hit a milestone. We turned the odometer on 100,000 viewers. And a few weeks later, I got this in the mail. This wonderful little plaque from YouTube. This is the silver play button. And this is displayed proudly on my wall, along with this, which is a letter from the CEO of YouTube congratulating me for this. And boy, that really meant a lot to me. And so to each and every one of my subscribers, thank you so much for making this possible. Now, if you haven't subscribed yet, please do, because there's a gold version of this, and I'd like to get that as well. And I only need 855,000 more of you to do that. So if you haven't subscribed, please do. And if you have, well, just tell 855,000 of your friends, and I'll be there. So until the next time we meet, please take care of yourself. Please once again allow me to wish you a very happy, healthy, and prosperous 2020. I hope all of your wishes come true this year, and I will see you again very soon here in the DroneBot workshop. Goodbye for now.